Okay, let's see now how our EasyLab Jewelry works with our Vertex PRO, so the professional version of our scanning software. Okay, we are with the scanner connected. We can see the green flag here in our icon and also here in our toolbar. And if we go in our service mode, we are in a live session. If we have problems here, we don't have the green flag. We don't see the green flag here in our icon, and also in our upper left corner, we don't see the green flag. We see yellow in case of the software is still trying to connect to the scanner, or we see a red flag in case the connection is not possible. Okay, so if we see green, means that we are doing well. And also the scanner, of course, is calibrated and ready to be used. So let's create a project, call it test project, okay? And we click on the OK button. The first big difference between this software and the basic one is that here you don't have a wizard mode. So here we have to work in a free mode without any wizard. It is a software for not for really beginners, but more for expert or users with some experience, because at the end you will see now it is not we will see now it is not a complex software always. Okay, so here we have a button to come back to the main menu, to come back to the service menu in case we need to calibrate, in case we need to turn on or off the color acquisition mode. Here we can open the project folder where we are saving the different scan, and here we can save the project every time we want. Okay, here we have a window where we can see our results listed while we are scanning, and here we have all the functions needed for running the scanner. So scan, edit a scan or a triangle mesh, run the global optimization, create the triangle mesh. Okay, so let's start acquiring the first scan. Here we can tell the software how many positions we want to acquire on the rotation axis. We can tell the software how many positions we want to acquire on the tilting axis. Let's do, for example, okay, something like that, or that. Okay, so we will add, we will scan the object from first with the minus 20 degrees, which is more from the top position, and then plus 15 more from the lateral surface. Here we can also choose what kind of alignment we want to run to register the different point clouds. Having the rotary table, the table axis alignment is always the best. And then we confirm and we go to the scanning menu. So let's position our object. Okay, and then we start. Okay, or we can decrease the quantity of the light because we see too much red. Always check the dark line on the object. That has to be with a good focus condition. In case it is not very good, you can always modify the focus using the slider. Okay, here is always a button in case you need to modify the parameters, or now we can go and scan. Always hitting the control button and starting the scan, we define the zero plane. Or if we directly scan, we scan everything. And then we will have to clean the point cloud. Okay, so now the scanner is moving the object, and now we have started the scan. So now we will see appearing some point clouds. For each position, we will see a different point cloud, okay? We can switch to the assigned color. Each color is a new scan. Of course, here to zoom, we always use the wheels of our mouse, and to rotate the object, it's is the right button of the mouse clicked, and then we move the mouse. Okay, so we are scanning our object more from the top direction. at the beginning, and then we will move to scan more the lateral surface. Here on the toolbar, now the different functions are not available because we are scanning, but at the end of the scan, it will be possible to run the integration. So to add single scans makes not a lot of sense when you run this kind of complex trajectory because you acquire a lot of data already. You can also cancel the last one point cloud added. You can enter the parameters, change them, and then scan the object again. Or in case of need, you can realign in a better way the last one integration done. And here is to enable the follow view mode. I mean, the mode where when I run the integration, moving the object on my screen, the scanner follows me. Okay, every time I need to cancel a scan, so to interrupt the scanning process, even if I'm not at 100%, I can click on cancel, then do what I need to do. So, for example, modify the parameters and then scan again. So here, if I zoom a lot, we have a lot of points, a lot of layers made by points overlapped, okay? And if I want to see if the data are missing, better to switch to the uniform, sharp uniform mode. And I can, in this way, it is easier to see if I have holes somewhere. Of course, what is below the object is something that I have tend to scan, moving the object in another position. Okay, so first scan is done. So I said we can integrate, we can cancel, delete the last integration done, we can modify the parameters and scan again, we can realign the redo the last alignment done by the software when we added the last integration, or we can select the follow view mode, okay? In this way, when I move the object on the screen, the scanner is following me. And so then when I run the integration, I'm acquiring exactly from that point of view, according, of course, with the limitations related to the two-axis rotary table. I cannot, here on the screen, I can move the object on 360, on all the degrees of freedom. On my scanner, I cannot do the same because I have only two axes. So now if the scan is good, we can confirm. If it is not good, we can modify the scanning parameters, scan it again, or click on previous and cancel everything. Let's go next. So we are confirming this scan. The object appears here in our toolbar. Okay, so in our tree, if now, okay, we have, we want to edit the object, it is enough to click on the editing button, and then we click on the selector we need, and we select what we want to keep, and then we crop. We also have the cut base tool. The plane is always parallel to the plane of the rotary stage. So when we move it or we click, everything is below becomes red. And when we click on apply, it disappears. Then we have the possibility to remove the outliers. Okay. Same filter we have also in our basic solution. It's an erosive filter, means that if I run it many times, then I create holes. I can also remove groups of outliers, okay, depending on the numbers that I specify here, we select more or less red areas. And when I click on remove, I remove the group of isolated points. And also I can remove the outliers based on the angle. So the best points are on a plane perpendicular to the acquisition direction. If the surface comes with an angle more parallel to the acquisition direction, the points have more noise, so they are not so good. So when I specify this angle here, everything has an angle bigger than 85 degrees is selected, and then when I click on remove outliers, they disappear. Okay, so I have a lot of tools for cleaning my point cloud. When I'm happy about my cleaning, I can click on next and confirm everything. I can also explode this point cloud. This is made by 25 single objects. So I'm going to explode it in 25 single scans, so then I can see each single scan on my screen. Okay, for a better organization, I can also group them in a single group, okay? And then when I switch to the sharp assigned and I click on the single scan, I can see it, okay? Every time I want to save, I can do it just clicking on save. So now we have to acquire also what is below. So let's move manually the object. Here, this part is missing. Let's start a new scan. Okay, here this time better if we do an acquisition starting from minus 35 degrees in order to see more the object from the top direction. And yes, we also need to acquire something about the lateral surface, because then we need to align the second scan on the first, so we need something in common. Okay, so we move our object. Okay, position like this one, light is good, the focus is good too, the parameters we have specified are good. So here we set robust when the object is like that one, white or with a not so dark color and opaque, robust is good. I don't need to go to the very robust. And then I click on the scan. Okay, so in this way, we scan the second position of our object. You see here in this picture that we are acquiring from this direction, and with different colors, we see different acquisitions. Now we are moving to scan more the lateral surface, so to have some surface in common with the first scan in order to align the second with the first one. Always when you have to align an object with another, you need something in common to create the overlap and then to minimize the distance between the two surfaces. Okay, second acquisition is done. We only have to confirm it, then clean and align with the first one. So we go next. Okay, again, we see it as a single group, but we can group it and then we can explode it to see the single components. Okay, so we have all the single scans acquired with different colors also when we go to the sharp assigned mode. Okay, let's edit the scans. We select everything and here we edit. Okay, and we also remove some outliers. Okay, looks better. Then we confirm. So now, if we select the two groups we have created, they are not aligned. First and second, all selected. Okay, they are not aligned. For doing that, I click on a group, then hitting Control, I hit on the other group, and then I click the right button of my mouse and I select all the items included inside the groups. Here I can also select in this way using the Control and Shift button. If I click Control, I add to the selection. If I click again, I come back. If I click Shift, I select everything between the first one and the second that I have selected. Okay, it works like in Windows Explorer at the end. So how to align the second one on the first one? We click on the second group, we click on align with group, and we select, here we have only one option, so we cannot make mistakes. We select the scan group one. The first group that I select is the one that I'm going to move. The second one that I select is the one that remains fixed. And always the software does an automatic alignment at the beginning. In case of need, it asks for one or more points. So here the alignment is not good. So I click on check alignment. I click on show floating in order to see only the green part here. And then when I create the same orientation on the red and on the green, and I click on this point and more or less this point, it gives me the correct alignment. Okay, here is the alignment. I click next, and I click next again to confirm. Now the two groups are aligned. More or less, we have acquired the whole surface of our object. Let's check it. We move to the sharp uniform color. We have two small holes here, but they are very easy to be closed by the software. So I would say we have all our object. What is missing is for sure the global optimization. So we select all our point clouds and we click on global optimization. And here we have to select the most important parameter is the search distance, which has to be smaller than the bigger thickness of our object. And then we compute the optimization. The software is now moving a little bit each single scan in order to find the best position for it. Okay, here we have a windows where we can see the situation before the alignment. So at the beginning, we had a standard deviation of our distance error of 19 microns and an average of 10. At the end, we are having 7 microns of average distance and 17 of standard deviation, which means that we have improved the alignment of our point clouds. And also we have the error for all the single clouds before and after the alignment. So we go next now. We are ready now for creating the triangle mesh. So with all the point clouds selected, we can click on the mesh generation. Here we have a few parameters. Okay, so yes, okay, the name of the mesh, if it is not the most important one, in case there is already a mesh named mesh, the software will create a new name for that. Here I have the maximum deviation, means the deviation that I'm accepting between the point and the triangles, it is the maximum deviation. Consider that if I say 5 microns, then the average deviation is more or less 1 micron. Okay, of course, the smaller is this deviation, the bigger is the quantity of the triangles created, because I'm asking the software to follow all the points when I create the mesh. Same is for the detail level. If I increase to high detail or very high detail, I will see all the details of my object, but I will have a lot of triangles. I can also decimate the mesh, but during the mesh creation process, but we always prefer to do that after, during the editing phase of the mesh. We can fill the small holes, and here we specify the bigger diameter of the hole that we want to fill. We can apply a thickness trying to compensate the spray when we use the spray. Okay, it's of course a constant uniform thickness, a uniform offset applied to the mesh. Impossible to apply the spray doing a perfectly uniform thickness, but it is always more than nothing. And in case we need a mesh with a texture, we can click on the texture creation icon here. It creates the Atlas texture in this way. And then we click on mesh generation. Okay, here we see that the process is running. Of course, also this software is able to work in parallel. You see here the scanning icon still available, so I don't need to wait for the mesh creation, but I can go ahead scanning other parts. Mesh. Okay, here in my tree, I have my triangle mesh done. Color is not good, but let me fix it. Just go here in my rendering options and change the color from dark to another one. For example, okay, this one a little bit different from the color used for the point clouds. So then I come back, and here is my triangle mesh. If I turn on the wireframe, here are all the triangles we have created, okay? So it takes time, but we are following all the details of the object. Here I still see my holes. I can click on the show boundary, okay? Here we have small holes, okay? How to fix them? Click on the edit selected data, and then here we have different tools. We can select parts and cancel. We can also decide what kind of selection we want to do, visible or pass-through, okay, because it's a mesh, so it's a surface. The difference between visible and pass-through is that if I select something in this way with the visible options set, I only select what is visible, so not the other part. If I do the same with the pass-through mode, I select everything is also behind the surface. Okay, so fill all, we can have the single fill all, supporting also the partial all filling, and we can specify what kind of filling strategy we want to use, so flat, curvature, or high curvature. Then we have the multiple fill all, where again we can define what kind of policy has to be used between flat, curvature, and high curvature. So curvature, let's say, and then we can click on the holes, or we can increase the slider here, okay, selecting bigger holes, and then we do the filling, okay. So now we are done. We have the D feature, so we select an area and then we smooth this area. We cancel the feature. We can invert the normals. We have the fix, the mesh doctor, the fix problem, topological problems tool. So we click on what we want to fix, and then we fix it. It makes a better mesh to be used then outside this software in a slicing software or in a CAD software. We also have the smoothing, very close to the one that we have in our basic solution. So we have to specify what kind of sensitivity we want to use, what kind of strength, what kind of protection, how many iterations we want to run. So here we have more parameters, and always we can specify the tolerance, so the maximum deviation between what we have now and what we will produce applying the smoothing. So we will always be sure that the resulting object will be different compared to the original one, of course, but inside the specified tolerance. Of course, the time needed for kind of features is always depending on how many triangles we are having, course on the power of the PC where we're running the software. In order to be faster, we use also the GPU. For this reason, we require an NVIDIA video board, because everything is developed on the NVIDIA GPU. So and we can run in parallel. We use everything is available on the PC, able to make calculations. So the result of the smoothing is that the gray areas are smoothed and the orange and blue areas are improved. Okay, I can always undo, coming back to the initial, to the original object, or I can redo. Okay, but always I'm sure that what I have produced here is close to the original object inside the 12 microns that I have specified. I can also remove the spikes, okay, or I can decimate. Here we are working with 1.6 million of triangles. So again, when I do the decimation, I have to specify the tolerance. So if I tell the software that I want a very small number of triangles, decimate means to substitute small triangles with bigger triangles. And of course, it means to have an approximation of the object. The resulting object will not be exactly the same, okay? So between, and of course, if I ask to have a very small number of triangles, means that I have to substitute small triangles with very big triangles. So I will have a big approximation, a big deformation of the object, but the software is working according to the tolerance. So if I say 4 microns and the software understands that the difference between the resulting object and the original one is more than 4 microns because I'm asking to have a very small number of triangles, it stops. So I have more triangles than what was my my target, but I'm sure that my object, my resulting object, is different compared to the original one, not more than the tolerance that I have specified. Okay, so here I have many tools for increasing the quality of my triangle mesh. With the target to produce a good mesh, so and then export it. So here is, for example, the remove spike tool. Increasing this slider, you can select more spikes, and when you remove the spikes, we are going to apply a special smoothing, removing on spikes are always created by reflections of the. So for this reason, we also suggest to run the outlier removals on the point cloud before creating the triangle mesh, because it helps in order to create meshes without a big number of spikes. It always depends on what is the target at the end, because sometimes you need to scan and then directly print the hand, so you need a good mesh. Sometimes you need to scan, but then you have to go to a CAD software and do a full reverse engineering. So yes, okay, you need a good scan, but the scan is not perfectly done. It always depends on where you want to go. Okay, here is the result without the spikes. You see the difference when I come back to the original object. Okay, so then I click next. I confirm my editing in D, and then I can always export object, clicking the right button of my mouse on the object in my tree. Okay, here export. Okay, I select my file format, and then I export my file. So here in this software, you also have the possibility, for example, entering this menu, you can also extract planes, cones, cylinders, spheres on the object. You can realign the object doing an alignment based on planes. So if I have planes on my object, I can find them, and then I can create my alignment with the my reference system. I can extract sections, so then I can export in a CAD software my sections. I can measure distances, point-to-point distances. I can estimate radius, making a selection and clicking here, I estimate my radius. Or I can, for example, when I have more than one mesh in my project, I can compare the meshes. So yes, first of all, I have to align the meshes, but the mesh alignment is working exactly in the same way. I just click on a mesh, I click align with, and then I align with the target mesh. And then when they are aligned, I can compare them and build a color map where I see, depending on the color, I can see the distance between the two meshes. Okay, so I have tools also for making some reverse engineer or for making also some quality inspection. Yes, the target is always to scan an object and create a good triangle mesh of the same object. So this is a software without a wizard mode, with a lot of additional parameters, but it is at the end easy to be used. Nothing is complex here. And of course, when you scan, the process is always the same. You scan, you clean, then you scan the other position, you clean, you align to the first scan, you understand in this way if parts are missing or not. If they are missing, then you scan again from another point of view, you clean and you align, you evaluate the situation another time, and then when you are done, you run the global optimization of all the point clouds, and then you create the triangle mesh, and then you can edit it and export. And that's it. Thank you.